Hey everyone. So I know you're all here because you're super into AI, especially the stuff that makes those crazy realistic images.
Yeah, it's pretty mind-blowing stuff.
It really is. And get this, today we're going deep on a brand new technique.
Oh, this is the randomized autoregressive visual generation,
Got
right?
it, RAR for
Oh,
short.
Chi-Chi.
Right. But honestly, even with a long name, it's way easier to understand than you'd think.
Well, that's good to hear.
Yeah. And what's really cool is we're sticking straight to the source.
Oh, you mean that paper from the ByteDance team?
Yep, that's the one.
Yeah.
We're going right to the research paper and even digging into all the extra stuff they released with it.
Nice. So we're getting, like, the cutting-edge info straight from the source.
Exactly. No middleman here.
Love that. And this paper, it's causing a stir already. It's really challenging how we think about AI image generation.
Well, it is going up against the heavy hitters, the diffusion models and those masked transformer models.
And holding its own. But what's wild is it's doing it all in a completely different way. It's like it's pulling ideas from, get this, language modeling.
Really? That's fascinating. I know, right? But before we get all into the nitty-gritty of how it works,
Yeah, good point.
it helps to understand the problem it's tackling.
Right, because it's solving a specific problem, right?
Exactly. So you've got those traditional autoregressive models. They're the brains behind things like, chatbots
Oh, sure. Yeah.
and translation stuff. They've always had trouble with images.
Why is that?
It all boils down to the type of data. Images and language, totally different beasts.
Oh, I see what you mean. Language is like one word after another, it flows. But images.
Way more multi-dimensional, right?
Yeah, like every single pixel is linked to all the others.
It's like a giant web of relationships.
Mhm.
Okay, picture this. You're describing a painting, but you can only look at it left to right, row by row.
Like reading a book.
Yeah, kind of. Would
Right.
you really grasp the whole thing? Probably not. You'd miss how all the parts work together.
Exactly. You'd miss the composition, the big picture.
It'd be like listening to a symphony, but only hearing one instrument at a time.
Perfect analogy. And that's basically what RRR is trying to crack.
Getting AI to understand the whole image all at once.
Nailed it, like grasping the context, but from every direction.
Okay, so that's the challenge. But how do these traditional models even try to generate images in the first place?
All right, so they break the image down.
Right, into smaller pieces.
Yep, called tokens. Think of them like the image's building blocks, like pixels, but bigger.
Okay, so they predict the next building block based on the ones before it.
Exactly, like solving a puzzle piece by piece. And for language, that works like a charm because, well, language flows in order.
But with images,
Not so much. You're shoving this multidimensional thing into a linear process.
forcing a square peg into a round hole.
Basically. And that's where these models hit their limit. They can make images, sure, but they lack that coherence, that global understanding.
The thing that makes a human-made image, or even one from those other AI models, feel whole.
Exactly. They just don't have that special something. And that's where RAR comes in, changing the game.
Okay, so spill the beans. What's RR's secret weapon?
Randomness.
Randomness. You're kidding, right? That sounds like it'd make things more confusing.
I know, right? But hold on, it's actually brilliant. Imagine you're learning a jigsaw puzzle. Always solving it the same way, same order.
You'd get good at that specific puzzle, but maybe not puzzles in general.
Right. But now shuffle those pieces up every time. You're forced to see how everything really connects.
You'd understand the whole picture way better.
Boom. That's the idea. RAR throws randomness into the mix during training. It shuffles up how it looks at those image tokens.
So it's seeing the image from tons of different perspectives.
Exactly.
Yeah.
And that forces it to learn the connections, the context in a way those other models just can't.
Wow, okay, I'm starting to get it. So it's not just random chaos. There's a method to the madness.
You got it.
But how does it actually work? Does it just, scramble the pixels?
It's a bit more elegant than that. It uses something called permutation.
Permutation.
Yeah, it takes those image tokens and shuffles them according to a specific pattern. It's not totally random, but it ensures the model sees a huge variety of arrangements.
So it's like a controlled chaos.
Exactly. And during training, it sees the same image shuffled in tons of different ways. This helps it build a really solid understanding of what's going on in the image.
So it's like showing the AI 1,000 different versions of the same picture.
1,000 puzzle variations. And the results, well, they're impressive. RAR is picking up on details and relationships that those other models miss completely.
Okay, I'm sold on the randomness thing.
Yeah.
But honestly, my brain is kind of fried trying to picture all this shuffling. Doesn't the AI get lost?
That's the million-dollar question, right? How does
Oh,
it know where everything goes in the final picture?
right.
Well, that's where another clever trick comes in: target-aware positional embedding.
Okay, you lost me.
Think of it this way. Each puzzle piece has a tiny compass.
A compass.
Yeah, so even if you shake them all up, each piece knows where it belongs in the big picture.
Oh, so each piece has its own internal GPS.
Exactly. And that's what target-aware positional embedding does. No matter how much you shuffle things, each piece knows its final destination.
That's brilliant. It's like even in all that chaos, there's this underlying order, like a secret code.
And that code is what keeps the AI from going bonkers and ensures it creates images that actually make sense.
Okay, this is all making sense now, but I gotta be honest, all this randomness talk, it's a lot. Does RAR ever, chill out?
You're right, it is a lot to process. And yes, actually, it does transition to a more structured approach during training. It's called randomness annealing.
Randomness? What now?
Think of it like calming the storm. At first, it's all random shuffling, super chaotic. But as the model learns, the randomness dials down.
So it's like exploration at first, then refining what it's learned.
Precisely. And get this, by the end of training, RAR actually uses the same method as those traditional models. That's standard raster scan order.
No way. So it goes from wild experimentation to, like, the tried and true method.
Yep. It's combining the best of both worlds. Exploring all those possibilities early on, then relying on what works best for the final product.
Smart.
It's like learning to swim, right? You try all sorts of wacky strokes first, but eventually you perfect the one that gets you across the pool fastest.
So RAR is taking that efficient approach, learn from everything, then use what works best.
Exactly, and that's a huge part of what makes it so effective. But there's even more to the story.
Like what?
We haven't even touched on how RAR uses tricks from language modeling to get crazy fast and efficient, but I think that's a conversation for part 2.
You're killing me. All right, fine. We'll save that for next time. But seriously, folks, we've covered a lot of ground already. We've talked about how RAR tackles the big problem of understanding images, how it uses randomness to its advantage, and how it eventually transitions to that more structured approach.
It's been a wild ride.
It really has. But trust me, it's even more interesting.
Oh, yeah.
So if you're as hooked as I am, make sure you come back for part 2 of our deep dive into RAR. We'll uncover even more secrets and see how this thing stacks up against the competition.
Can't wait.
Me neither. See y'all then. All right, so we're back. Still geeking out over RAR, this randomized autoregressive visual generation thing.
Still with me.
Oh, absolutely. I'm hooked. Last time we left off with RAR's secret sauce, using randomness to get a better grip on images.
Right, like shaking up those puzzle pieces to see the whole picture.
Exactly. We also dropped a bombshell. Something about how RAR borrows techniques from language modeling for speed and efficiency.
Oh, yeah. That's where things get really wild.
So spill it. What's the connection between making images and, like, chatbots?
It's all about bridging the gap between language and vision. For ages, AI research treated them as totally separate things.
Different tools for different jobs.
Right, but RAR is like, hold on, what if we use the same principles for both?
And it works.
It does, and that's huge. It hints that maybe we're moving towards a more unified AI, one that understands both words and pictures.
Whoa. So the same tech that powers chatbots could make images too.
Exactly. It's like this underlying framework that can handle both. Think about it. You could describe a scene in words, and the AI just, poof, creates a realistic image.
No way. Like, tell it a cat wearing a tiny hat riding a unicorn on a beach, and it just makes it.
Exactly. Or you could sketch a rough design, and it fills in the details super realistically.
That's mind-blowing, like giving AI a universal language.
It really is. Think about the impact on things like content creation, design, even science.
I can see it, like making visuals for anything instantly. Websites, social media, you name it.
Or even personalized stuff, images tailored to each person's taste.
Whoa, that'd change marketing forever.
Yeah.
But what about the science part?
Imagine visualizing complex data in a way that's both accurate and beautiful. It revolutionized how we understand the world.
And for artists and designers? It'd be like having an AI partner that can help bring any vision to life.
It's a whole new level of creative collaboration. But, okay, enough daydreaming. Let's get back to how RR actually pulls this off.
Right, the speed and efficiency thing. I mentioned language modeling tricks.
Yep. One big one is called KV caching.
KV what now?
It basically lets the model store and reuse calculations it's already done, like having a super memory.
So it doesn't have to start from scratch every single time.
Exactly. And that's a lifesaver for these autoregressive models. Remember, they work step by step. each new piece has to be calculated based on all the ones before it.
And that adds up fast.
Oh, yeah. But KV caching streamlines the whole process, making it way faster and more efficient.
So it's like giving the AI a shortcut.
You got it. And the paper actually points this out as a key reason why RR is so much faster than, say, those diffusion models.
So we've got a model that's top of the line in performance A&D, super efficient.
Pretty impressive.
This.
Right?
But is it all sunshine and roses? Are there any downsides to this whole RAR thing?
Well, no model is perfect, and RAR, being an autoregressive model, still faces that sequential generation challenge.
Meaning?
It has to build the image piece by piece, right? So some parts are always created before others, and that can sometimes lead to inconsistencies or like the image doesn't feel perfectly cohesive.
So even with all the bidirectional context stuff, there's still room for improvement.
There always is, but honestly, that's a challenge for the whole field, not just RAR.
Even those other fancy models struggle with it.
Oh, yeah. Making AI that truly gets the essence of an image like we humans do, that's the holy grail.
So RAR is a big step forward, but the journey continues.
Exactly. Speaking of the journey, the paper has this cool section where they revisit an old study about scan orders.
Scan orders, like how you read the image.
Yep. A few years back, they tested all sorts of orders, row majors, spirals, you name it.
So they were looking for the most efficient way to process the image.
Exactly. And guess what? Despite all the fancy AI development since then, the good old row major order, the raster scan, still wins.
Really? Back to basics.
It just goes to show sometimes the simplest approach is the best. And it highlights how clever RAR is.
How so?
Well, it uses those random permutations to learn during training. But when it comes to actually making the image, it sticks with what works, the raster order.
So it's like explore everything, but stick with the classics for the final product.
You got it.
And this whole scan order thing, it reminds me of something else the paper mentioned, how RAR can actually benefit from all the work done on those big language models.
Oh, right. Because it's built on those core autoregressive principles, it can use all the cool tricks they've developed, like that KV caching we talked about.
It's like if you have a great set of tools for building a house, you could probably use them to build a spaceship too, right?
Exactly. And that's huge for RAR. It means as those language models get even better, RAR will level up right along with them.
So it's like piggybacking on the success of another field.
Exactly.
This is all incredibly exciting. We've got a model that's breaking new ground, super efficient, and poised to get even better in the future.
It's a good time to be an AI, that's for sure.
It really is. But with all this potential, I can't help but wonder, what are we going to see RAR used for in, say, the next few years?
Oh, the possibilities are endless. One area that's ripe for disruption is content creation.
You mean like making images for websites and stuff?
Yeah. Imagine being able to whip up high-quality visuals with just a few words, or even a rough sketch. It'd be a game changer for marketers, bloggers, anyone who needs visuals fast.
No more stock photos.
Exactly. And think about personalized content, tailoring images to each user's preferences.
Whoa! Targeted ads, but like on a whole new level.
And then there's the design world. Architects, product designers, fashion designers, they could use AI to explore ideas way faster.
So they could sketch a basic idea and the AI would generate all these variations.
Exactly. It'd be like having an AI brainstorming partner. And because RAR is so efficient, these tools could be built right into the software they already use.
It revolutionized the design process.
It would. We're talking faster iteration, more creativity, the whole shebang.
This is starting to sound less like science fiction and more like, well, the near future.
It is, but honestly, we're just scratching the surface. As researchers dig deeper into RAR, I think we'll see applications we haven't even dreamed of yet.
It's like opening a door to a whole new world of possibilities.
It really is.
Well, I don't know about you, but my brain is officially fried. All this RAR talk has been amazing, but I need a minute to process.
Me too. But don't worry, everyone. We're not done yet.
We'll be back soon to wrap up our deep dive into RAR and talk about what it all means for the future of AI.
Looking forward to it.
Me too. See you all in a bit. Okay, so we're back, and I'm still buzzing about RAR. We've gone deep on how it works, why it's so cool.
All those clever tricks, right?
Totally. But now I want to zoom out. Big picture time. What does RAR's success tell us about AI's future?
Oh, that's a good question. I think one big takeaway is the power of cross-pollination between different AI fields.
You mean taking ideas from one area and using them in another, like RAR using language model stuff for images?
Exactly. For so long, those areas were like separate silos, right? But RER shows that breaking down those walls can lead to awesome breakthroughs.
It's like realizing the same tools that build a bridge can also build a skyscraper.
Perfect analogy, and I think we'll see even more of this in the future. Robotics, language processing, all these fields learning from each other.
So we can expect even more crazy innovation as researchers get creative.
Absolutely. And that leads to another big implication of RER, more unified, versatile AI systems.
Oh yeah, you mentioned that before. AI that gets both text and images.
Right. RER is a step towards AI that can communicate more like us, you know?
It's like teaching AI a new language, one with both words and pictures.
Exactly. And as AI gets more versatile, it can tackle way more complex problems. Imagine the possibilities.
This could change everything, from science to art.
Imagine AI helping scientists visualize data in totally new ways, or helping artists create entirely new forms of art.
It's mind-blowing. We're really seeing AI evolve before our eyes.
We are. But it's important to remember we're still early in this journey. RAR is just one example of what's happening.
It's like we're just peeking into this amazing new world.
Exactly. But as AI keeps advancing, we got to have those tough conversations too, right? About the ethics, the impact on society.
Making sure AI is used for good, that it benefits everyone.
That's a conversation we need to have right now, not later.
Couldn't agree more. Well, I think that's a great place to wrap up our deep dive into RAR.
We've really gone through it, haven't we?
From the technical details to the big picture implications, we covered a lot. I hope everyone listening has a better understanding of this amazing new technology.
And a newfound appreciation for the possibilities it opens up.
Absolutely. And for anyone who wants to go even deeper, we'll link to the research paper and all the extra materials in the show notes.
Go check it out.
It's a fascinating read, trust me. But for now, that's a wrap on our deep dive into randomized autoregressive visual generation.
Thanks for joining us.
Until next time, keep exploring, keep asking those tough questions, and most importantly, keep learning.